All right, so if we are given this graph or this function here and we want to figure out maybe what some of our output values are using function notation, let's say we were given something that said f of -1 equals something. And we want to figure out what is my output when my input is -1. Okay, so I'm going to go and find -1 on my graph, which is right here. And I'm going to see, well, where does that hit my graph? Well, nowhere, right? If my input is -1, I don't have an output that matches up with that input. And so that is where domain and range comes in. It's just a way for us to describe what values are a part of our function. So if we're talking about our x values, that is our domain. Our x values, we can see that the first x value where we see our graph is 0. And then if we continue over, our graph stops at x equals 4. So it doesn't really make sense for us to talk about f of -1 because that's not a part of our function. Or if we were to continue, if we said f of 5, that's also not a part of our function. So the domain of a function are the x values that are valid, or the x values that are a part of the function, the x values that make sense in a graph or in a function, however you want to think about it, but it's the x values of your function. So -1 is not a part of our function, and 5 is not a part of our function, or 6, or -2. The domain of this function is 0 to 4, and we'll talk about later how to write that in something called interval notation, but just for right now, we'll just think about it as the idea of 0 to 4, and it includes 0 and it includes 4, right? Because 4 is a part of our graph and 0 is a part of our graph and everything in between.
All right, similarly, we can look at our outputs. What if they asked us, when is f of x equal to -7? Well, looking on my graph, it doesn't even go down this far, right? -7 isn't even a part or an option here. Or what if f of x is 6? What if my output is 6? Well, there is no output. Like this function, this graph doesn't go that far to reach 6. And so just like Emma was showing us with domain, we can restrict our x values. We can also restrict our y values. And that is what the range is. The range is the set of all valid y values in the function, or the y values that make sense. So in this case, our y values are lowest. Our graph goes is here at 1. So we're starting here at 1 and it goes all the way up and stops right here at 5. So we would say our range in this case is from 1 to 5. We will learn later how to write this in a more mathematical way, but this lets us know that my outputs exist from 1 up to 5 and anything outside of that doesn't exist.
All right, so now we're going to talk about how to write domain and range in a more mathematical way. So 0 to 4 for our domain is very true, and 1 to 5 for our range is also very true. But one way that we can write it to help us better explain is something called interval notation. And this is just a way for us to quickly write what the domain and range is without having to list out the values or to write 2 in between. So because 0 is a part of our domain, we're going to start with a bracket. And this bracket just represents that the value next to the bracket is included. So we're saying our domain starts at 0 and 0 is included, and then we're going to draw a comma. And this just tells us that all the values in between 0 and 4 are included in our domain. So we could say it's not just 1, 2, and 3, it's 1/2, or 1.5, or 2.5, or 3.5, or 1.75. All of these values are included in our domain. And then we are going to end with a bracket again, because that bracket tells us that 4 is also included. So our domain goes from 0 to 4 with 0 and 4 included. And similarly, we'll write that with the range. So 1 is included in our range because 1 is a part of that function. If we said f of x equals 1, then we could say, well, x is 0, y is 1, right? So 1 is included and it goes until 5, and 5 is also included, and all of these values in between. So this is how to write domain and range in interval notation. And we'll talk about later what to do if a value is not included in the function.
All right, here's another example where we want to find the domain and range. Remember, our domain are all the valid x values of our function, or the x values that make sense. So looking at our graph here, remember x goes from left to right. So it looks like my graph starts here at x equals 0. Okay? And my graph continues moving until I reach here, and then it stops, right? I don't have any x values going on over here. There's no 4 or anything like that, right? So my x value stops here at 3. Sorry, that might be hard to read. 3. Okay, so my domain here goes from 0 to 3. However, if we notice, this is an open circle. So this means that this is like a gap in the graph. So it goes all the way until like even 2.99999, but once it hits 3, it does not exist, right? So to write this for our domain, we would say our domain goes from 0 to 3, but does not include 3. Like it goes up until 3 and then there's a hole. So to write that in interval notation, we would say bracket 0, because 0 is included, and the comma means I'm going all the values in between until 3, but I don't want to include 3. So in order to show I'm not including 3, because there's a hole in the graph, it does not exist, I'm going to do a parentheses to show that it's from 0 until 3, but not including 3. And so that is how we do our domain with an open circle. Let's look at our range. Remember, our range are all our valid y values. So my y value is my up and down, so I'm going to be looking here. Okay, looks like I start at 2, right? There's no y values that are like 1 or 0 or negative, so I start here at 2. And I go all the way up until I hit 3. Okay, so this is kind of a smaller range. I'm going from 2 to 3. It goes from 2 to 3. And then I also want to look again for those open and closed circles. So I know 2 is closed, which means 2 is a part of my graph. So 2 is included. I go all the way up until 3. If I look at 3, again, 3 is an open circle. So this is not part of my graph. So I'm going to do a close parentheses to show that it is not part of my graph. So it goes from 2 until 3, but not including 3.
All right, guys, now we're going to look at this example here. So there's a couple things that are going on in this graph that we're going to have to address when we're writing our domain and range. But essentially, it's the same thing that we've done in the previous examples, with domain and range being our x values and our y values that are part of our function. So let's start with our domain. With domain, we always start on the left side of our graph or from our most negative numbers, and we work towards our positive numbers. So with this graph in particular, it has an arrow. And what this arrow tells us is that this graph is going to keep on going forever. So I could continue this line down forever. So on this graph, it looks like maybe our domain would start at maybe here like -6, right? But because of this arrow, it's going to keep going forever. So our domain is actually going to be continuing on infinitely in the negative direction. So our domain is going to start at -infinity. And so that's totally all right to have an infinity in your domain. Anytime you have an arrow, you know that you're going to write infinity somewhere in your domain and range, because the function is going to be infinitely continuous either way. Okay, and so when it comes to brackets and parentheses, since infinity isn't actually a number that we can reach, we're going to have a parentheses on this one, because infinity or negative infinity is not included in our function, but our function is getting really, really, really close to it, as in it's getting infinitely small. So we know that our domain starts at -infinity, and then as we move in the positive direction, we can see that right here is where our domain stops before we have this gap, and we'll address that gap in a minute. But the first part of our domain, you can see that it goes from -infinity to -2, and because this circle right here is filled in, we know that -2 is included in that domain. So we can say that this part of our function goes from -infinity to -2. All right, so now we have to address this gap right here, right? So we know that our domain doesn't stop right here and then it does continue again. It stops right here and then it starts again here at 0. But from this -2 to 0, there is nothing a part of our domain. So we have to address that when we write our domain. And that's where this union symbol comes in. And so this symbol just tells us that our domain is this part, and then there's another part of our domain, and that there's some sort of gap in between. Okay, so then if we look at our graph, the second part of our domain starts here at x equals 0, and because of this open circle, it means that we're going to have a parentheses here, not a bracket. So it starts at 0, and it continues on till 1, 2, 3, x equals 3. And then, because of this open circle, we again will put a parentheses. So the domain of this function can be represented by this whole piece right here. It goes from -infinity to -2, and then there's a gap, and then it continues again from 0 until 3.
All right, so now we're going to talk about the range. Remember that the range of a graph are all the possible y values that make sense or that are valid. So in this case, remember we want to go from low to high when we're writing, just like we did with the domain. We went from left to right, bottom to top with range. So looking at the bottom, -infinity is my lowest part of my graph, -infinity, and I go all the way up until I hit right here. -1. So it goes up and reaches -1. Because this is a closed circle, so -1 is included, so I'm going to do a closed bracket. Looks like I've got a gap again in my graph, and so because I have a gap, I'm going to use this union. I'm joining this part of my range with my other part of my range. So my range continues again, looks like right here at this open circle, which is at 2, and 2 is not part of our graph because it's an open circle, so 2 is not part of our graph, and it goes all the way up until 5. So it looks like we hit right here at 5. And so I'm going to do 2 comma 5 and again close parentheses because 5 is not included in my graph.